algorithm and bipartite graphs, well, what is it? Where do we use it? It's a way to allocate employees to machines in order to minimize the time taken to finish the tasks. In other words, in real life, so you want to be efficient, especially if you're a supervisor, so you want to make use of your employees and make use of which employee suits for a particular machinery in order to get things done on an efficient way, and that time is gold. All right, let's have a look at this example. So three volunteer workers, Joe, Meg, and Ali, are available to help with 3 jobs. The time in minutes in which each worker is able to complete each task is given in the table opposite. Which allocation of workers to jobs will enable the jobs to be completed in the minimum time? So we want to achieve the minimum possible time. In order to do so we need to make use of the Hungarian algorithm. And after that, we do a bipartite, and we'll have a look at how that's done. Okay, now, so first and foremost, we do something called row reduction. And row reduction, column reduction, then we do all uncovered, subtract, and addition where the lines cross. Oh, what is that supposed to mean? All right, let's have a look. So let's make a rectangle again. So we're going to put this rectangle. All right, now, I think, did I make more boxes? Okay, now, so let's have a look at what a row reduction, column reduction is supposed to mean. So we're talking about these numbers here. That's a row, so we're going to reduce. In other words, pick the smallest number in this row and subtract from all other numbers. So in this case, 20 is the smallest, so that's going to be subtract 20 from this, 20 from that. That's going to give me 0, 0. So that's going to be 16. All right, we're going to do the same thing again with the next one here. So that's going to be 0 again. So the smallest number in this case here is 16. So that's 0, that's 4, that is 18. Okay, now the next one is, and this one here, 26 is the smallest. So that's going to be 0, 0 again, and that's going to be 18. All right, then we're going to use the smallest number of crosses to cover the zeros. So this one here. All right, now, so we're going to cover that 0. That's the smallest number of lines to cover the 0. So we're going to use that line again. We covered all the zeros. So that step 1 was called row reduction. Remember, row reduction. Let me write down step 1, row reduction. In other words, you're subtracting the smallest number from all other numbers. So second step is we're going to do column reduction now. Column reduction. Okay, step 2. All right, now let's do again the box again. So the column that's uncovered, which is this column here, pick the smallest number and subtract from all other numbers. So that's going to give me, what's that, 2. So that one was 28, isn't it? So this one was supposed to be 28. Yeah, 28. I made a mistake there. 28. Okay, now here, and the smallest number in this case is 16. So that's going to give me 0. So subtract the smallest number from all other numbers. This column here. So write down this one here as which is 14, and that's going to be 2. So now we're going to use the minimum number of lines to cover all the zeros. So in this case here, we've done our column reduction. So let's use the minimum number of zeros to cover all. So now it's different color. So we're going to use that. We've covered that line. We've covered that as well. So now step 3 is to all uncovered numbers, uncovered. So we have covered those zeros. So now all uncovered numbers, uncovered, subtract the smallest. And subtract the smallest from all the other numbers. The smallest uncovered has to be smallest uncovered. Uncovered subtract from all uncovered numbers, it should be. Alright. So these are not covered, so that in this case here we only have 4 and 14. So this 4 is the smallest, and where there is a cross, yeah, add 1 to it. Alright, now let's do that. And add 1 to where the 2 lines cross. Where the 2 lines cross, so in this case here we add 1 to that section, in that section here. So we add 1 to this because the 2 lines cross the vertical and the horizontal line, and they add 1 to that. And we don't change anything else. And after that, let's see how we go. All right, now. All right. So we added 1 to that. So that's going to be 1. That's 0. That's 1 again because that's. So those are the ones they don't change. And remember that subtract uncovered number, subtract from the small. What? This one is the smallest. So that's going to be 0. That's 10. That's 2. That's 0. So now again, we have to look at our different workers now. So now we have done all the requirements. So the next thing we have to do is see. So this person, Ali, there's only 1 0 on Ali. And there are 2 zeros on Megan. There are 2 zeros. Oops, should probably use this one that's a bit lighter. Not a good pick. Alright, now, so there are 2 zeros on Megan. And what's that? 2 zeros. So that means Ali can only do, so now this is when we do the bipartite. Bipartite. In other words, allocating the task. Bipartite. So we're going to have J, M, A. And the 3 jobs that need to be done is A, B, C. So Ali only has got 1 0. So that means Ali can only do, Ali can only do task B. Alright, we're done with Ali. So Megan can only do, because that's taken by Ali, because only has 1 0. So Megan and also Joe cannot do that, so that's gone. So the only option that Megan has is to do task A. So Megan can do only task A, and Joe can do task C. And that is basically the bipartite, in other words, allocating the task. So what is the minimum duration that these 3 individuals can work on? So remember that Ali has taken 26, Megan has taken 16, and Joe has taken 36, because that's going to give us the minimum. Yeah, so that's going to give me, so if I do that, so that's going to give me 36, 16. So it's going to take 78 minutes altogether. All right, I hope that is clear to do the bipartite. And all right.